To begin with, let's consider a body of mass m lying on an inclined plane with an angle theta. What would happen if the angle of inclination is increased? Definitely the body is going to roll down or slide down. Well, what could be the reason for it? We all know that there is a gravitational force acting on any body which is of magnitude m times acceleration due to gravity, which is g. So let's try and get a little more elaborate onto it. Like, what is force? A force is generally a push or a pull which can make a body from the state of rest to a motion, and also it can change the uniform motion of a body or even change the direction of it. It can also change the shape of a body. Let us now examine the formula for force. We know the force is equal to mass times acceleration. What is mass? Mass represents the amount of matter in a particular object. We know its SI unit is in kilogram. So naturally, the more the mass of a body, the more difficult it is to move. So the more force is required. Now let us assume if the body is not in motion, that means its acceleration is zero. So does that mean the force itself is zero? As per the formula, it's right, the force is zero. But then what happens to the entire force put by the person onto the elephant, though the elephant is not moving? That means there is an opposite force in reaction to the applied force by the person. Also, it's worth noting that the force mentioned on the above occasion is the net force. That means is the sum of all forces. So, for a body to start its motion, the applied force need to be greater than all the opposition force such as friction. And once the body starts its motion, if we can provide the same amount of force equivalent to the kinetic friction, then the body can maintain the same velocity, and in effect the net force would be zero. Let's try and explore the real meaning of acceleration. Acceleration is the change in velocity over time. Or in simple terms, if a body is set to accelerate with 20 meters per second square, it means its velocity increases or decreases by 20 meters per second for every second of its travel. Let's take an example of a free falling stone and try to figure out what its velocity would be after 10 seconds. We know initially the body is at rest and hence its initial velocity would be zero, and then the body would fall under the influence of gravity with an acceleration of 9.8 meters per second square, which would be a constant, and thereby its velocity after 10 seconds of its travel would be acceleration due to gravity multiplied by 10 seconds, which was 98 meters per second. To cross check, let's analyze the same with the equation of motion we had learned during our school days. V equal to u plus at. We know v is the final velocity, u is the initial velocity, a is the acceleration, and t is time of travel. Substituting the values, we all know what is the basic difference between speed, velocity, and acceleration. That speed is a scalar quantity, which means it can be fully represented in means of numerical value. Velocity is a vector and acceleration is also a vector quantity. That means it requires a direction apart from the numerical value or magnitude. It would be also interesting to note that even if a body moves with a constant speed, If it changes its direction, the body would still be accelerating. Also, if a body moves with a constant velocity, it means its acceleration would be zero. As we know that acceleration due to gravity is a constant, it means that any body, any freely falling body, irrespective of its mass, would accelerate at the same rate. And this is the prime reason why a heavier object do not fall faster than a lighter object. As explained earlier, the more time a freely falling body takes to reach the ground, the more velocity it attains and more momentum it gains. And this is the reason why a lighter object when dropped from a higher height hit harder than a heavier object from a lower height. Let us consider a person standing on the ground. We know there will be a force exerted by the body towards the center of the ground, which is mass times acceleration due to gravity. It's also worth noting the weight of the body is the same as this force. That means in a free fall, the net force of an object equals its weight. Force and weight both are vector quantities, which means a 50 Newton of force is not the full description of it until a direction is not specified. It should also be noted, for the force Fg acting onto the ground, there should be an equal and opposite reaction force, which is called as a normal force. And this force always acts in perpendicular to the horizontal of that particular plane. Coming back to our scenario of body of mass m lying on an inclined plane, we know there is a gravitational force acting downwards and also a normal force acting in perpendicular to the inclined plane. For our convenience, let us split up the gravitational force onto components, which is perpendicular and parallel to the inclined plane. For the object to stay on the inclined plane, the perpendicular component of the gravitational force need to be negated by the normal force, which is n in this case. But then how about the parallel component of the force? That should be pulling the body downwards. Definitely, there should be an opposing and a negating force, which is frictional force, Ff in this case. Let us now try to find out the magnitude of the perpendicular and parallel components of gravitational force. We know the sum of all angles in a triangle is 180 degree, and our sketch being a right angle triangle, we can arrive at angle x as 90 minus theta. Let's recollect from our geometry classes that when two parallel lines are cut by a transverse line, the alternate interior angles are equal. Applying the same theory to our sketch and on completing the triangle ABC, which is a right angle triangle, we can arrive at the angle of side AB and BC as 90 minus theta. The sum of all angles in a triangle being 180 degree, we can arrive at angle Y as theta, which is the same as the inclination angle. Now let's apply some basic trigonometry to arrive at the figures of Fg parallel and Fg perpendicular. We know sin theta is opposite side by hypotenuse, and opposite side is Fg parallel in our case, and Fg is the hypotenuse, which is always the opposite side of the perpendicular. And upon solving, we come to the conclusion that Fg parallel is Fg into sin theta. Substituting the value for Fg as we know is m into g, we come to the fact that Fg parallel is mg times sin theta. Similarly, applying cosine theta, we can arrive at the Fg perpendicular value to be Fg times cos theta, and substituting the value, we can arrive at mg times cos theta.
Finally, let's analyze the practical implication of the formulas. For that, let's consider the object to be laying on the ground, that is, the value of theta being 0. Upon substituting the value for theta as 0, we get the perpendicular component of gravitational force to be m times g, which is the weight of the body itself as was explained before, and the parallel component of gravitational force to be 0, indicating that the body is free from any sliding and frictional forces.